probably for all those who were around yesterday, I'm Zerafa. I'm one of the founders of the fair, together with Brian and Charles. And together with Brian, we worked on this research, which I have to say that part of this paper was financed by the Malta Council for Science and Technology. Okay, and the idea is we used a drone to measure small. We call it a city. It's not really a city. It's more like a town. All right, it's a small town, and we obtained real data from installed PV systems, and we measured how much potential there is to get PV panels if we use this only area for which we install this area with PV panels. Okay. So, which city is it? It is Senglia, or we call it also Isla. It's very close to here. It's across the harbor. It's only 0.2 kilometers squared. So basically, it's like two ground pitches connected together. Why we selected this area? Because it's highly dense with buildings. Okay, practically there is only one small garden at the end of the town or village or city. Okay, and as you can see, this is an image which we took with the drone, and we merged the orthophoto with our software, so that it's a software which we built, it's not a software which we purchased. Okay, and we took a lot of photos. I'm going to explain it. Okay, and this is Isla. As you can see, there are a lot of buildings. Buildings. Why also we took this area? Because the buildings are made in a grid pattern. Okay, so they are made in a grid patterns. They are made of blocks. This is a block. This is another block. But within one block, there could be multiple roofs. Okay, so as you can see in this block, there are three different roofs with 3 different elevations. All right. As I mentioned, each block there are multiple houses. For example, in this block there could be like 5 or 6 different families. We didn't go into how much families were living over there. We were only interested for the overall surface area. All right. Some other setbacks, which there are different elevations. There is a perimeter wall, which you could see here. So that one automatically will produce shade if you put the buildings. All right. And the last. Also, there are like internal yards. For example, this one here, that is an internal yard. All right. So if there is a block, there is an internal yard, there is the perimeter. So we have to pay attention for these setbacks. All right. What drone did we use? We used the matrix DJI 210. All right. We took another photos. Basically, it means bird's eye view. You look down 90 degrees. All right. So that we get like an orthophoto from looking from up above. All right, the photos were overlapping 80%, and then we generated, as I said, from our software, the DJI orthophoto, okay, and we measured the roofs and blocks, each and every block, all right, through a JavaScript software which we created, and so on and so forth. Why we decided to use drones rather than satellite images? I'm sure that every one of you used Google Maps. If you zoom out and zoom in when Google Maps, and you try to get measuring, and this is something that we did, you are going to obtain different measuring. Google Maps are not accurate, and because of the way the images are portrayed. So with drones, we got better accurate results. Okay, just to give you an idea, for an orthophoto of 0.2 kilometers squared, you can get for the whole orthophoto an accuracy of less than 2 meters. Okay, that's why we decided to go for another geo orthophoto made up from drones. Okay, each pixel for each drone represents 3 centimeters in real life. Okay. So what PV? So second step. So first we obtained the data from the drones of the area. The second step is we obtained the data from existing PV panels. All right, we used 3 PV panels which were installed in 3 neighboring locations which are close to Isla, one in Tarshin, one in Vgura, and one in Kalkara. Okay, and we obtained the data over a period of 2 years from these 3 different installations. Okay, it's important to note. I'm not going to mention the technical specs. They are written over there. They are written also on the paper. of the PV panels, but I need to mention that all PV panels, they had all PV systems, they had 12 panels. All of them, the surface area of each and every them was 20.56 meters squared, and all of them were installed at an inclination angle of 15. So the real surface area, they are 20.56. The real surface area, it's more like 19.5. But for the purpose of this paper, we used an surface area of 20.56, and obviously we were excluding the shades, all right? We were not including in our area, we were not including the shading in the area which we have used. All right, so exactly the surface area, calculated with trigonometry, is 19.86, and the proper area was 20.56. We used two different types of panels, two systems in Tarshin and Kalkara. There were panels which were rated at 335 watts each. The one in Tarshin was rated at 315. So the Gura and the Kalkara was at 315. The one at the other side was 115 watts. All right, so we got the data with the drones, we got the data in real for 2 years, 2020, 2021, from 3 different sites. All right, and I'm going to jump directly to results. So there were a total of 63 blocks at Isla. All right, so there were a total of 63 blocks. The number of units, although there were 63 blocks, so the number of roofs with the perimeters, which I mentioned, was 752. Okay, the total area of the block was 64703 meters squared. Okay, we calculated some results. Okay, these were the results which were generated, the power generation from all sides. Okay, the blue is for one side, the orange is for the other side, the gray is for the last side. Okay, Tarshin, Kalkara, the orange, the blue is Gura, Tarshin is the gray one. And we plotted down, we obtained how much power was generated each and every month, all right, for all sides. Okay. So just to jump to the conclusions, the results showed that the total generation from all the 6 sites in kilowatts was 6,400 in Gura, 6,200 in Tarshin. Average power for 2 years was 6,300. And the most interesting thing is the last slide. If we use a potential of 30% space only from Isla, we would be able, and if we install 335 panels, so Isla is, as I said, 0.2 kilometers squared. If we use 30% of the roofs available, only 30%, we would be able to generate 6,000 megawatts. All right, if we use 335 watts panels, if we use 115 watt panels at a 30% on roofs located at Isla, we would be able to generate 4,000 megawatts. Sorry, 4,000 megawatt generation. All right. So this morning, for your comparison, I did some numbers. All right. In Malta, every year we generate from PV panels 242 megawatts. If we use 30% at Isla, that number could go up from 242 to 250. Okay, and this is only one location, which is 0.2 kilometers squared. All right.
Okay. Thank you very much. Time for one question. Yeah. I have a question. I'm sure you will be doing a network analysis as well to see if the network can handle these penetrations locally, or do you have the capacity of the network to?
So let me give you a brief introduction. I do mainly work with images. I do not work. So we combine the AI with Brian. Our next study, rather than networking, is going to be to automate, because we calculated the setbacks and we said let's use 30% and 35%. We didn't go into how much setbacks there are. So next study, we want to be more precise by calculating the shades which are created by the perimeter walls, and also we see the sun at 12 and from the east and to the from coming up from the east and going up down to the west. We want to be more accurate, and rather than say we use 30% of the space, we would say there is a total area of, let's say, 60% available to install our PV panels. So that is our next step. Eventually, I'm sure that we're going to integrate also the networking. But in my case, this was the first study where through which I focused on power
It's a very good
generation.
first step.
So this was because my area of study is totally different. So I decided to start with this.
Okay.
Okay.
Thank you very much. Thank you.